Hello developers, let's start developing. Today we're gonna tackle the day 3 of the 2023 Advent of Code. I've read through the problem and it's kind of a weird one because we're gonna have to do something with matrices. So what we have is some kind of a gondola lift that has a broken engine and we need to fix it. So all this, the star, the hash, the other star, the plus, the dollar, those are some kind of machine components. And if we, let's zoom on it a bit. So this means that there are some IDs or numbers or whatever's attached to this component. And those are the numbers that are in any way connected with it. So we have the 467 number, which is connected to it diagonally, and we have 35, which is connected below that. And this thing is connected with this element, this is connected with that element, this is connected, this element is connected with this ID, this with this, and these two numbers are connected with this element. So we have 114 and 58 over here, which are basically not connected to anything. And it seems that they were kind of supposed to be connected to something. So we need to find them out and sum all the others. So basically we need to sum all the connected ones. The schematic is a bit on the bigger side. And it seems that we're gonna have to do some magic in order to actually do some things with it. Okay, so what we need to do is take this small example, and sometimes there are problems when we are getting the small examples with enters on last lines and things like that. But let's see what the huge example looks like. Yeah, it's 140 lines. So we're going back to the small example and we are making sure that it doesn't end with an enter sign. So we need to parse this and somehow make sure that we process it. So at this moment, I kind of have no idea what the input will be, but it won't be an array of strings. Most likely it will be some kind of engine, let's call it. Yeah. So that engine will have elements, which will be an array of element. And it will also have. Now, the element is just some kind of a symbol on a specific location, and it's always a one character symbol. So, what we can do to display an element, we don't need any of those, and it doesn't need to be a class. It's gonna be an interface, and it's gonna have an X and a Y. Actually, of course, I think it makes sense. Yeah, I love interfaces. To have an interface that we're gonna call point. That's of course gonna have an X, that's a number, and a Y, that's a number. And we're gonna, the element is a kind of a, yeah, an element is a kind of a point. So it extends this, we don't need an X, we don't need a Y, what we need is the value which is a string. And then we can have a, what did the task call them? I always try to program in the domain of the problem. So those are part numbers. Okay. And actually, I'll do something like this. I will have the value, which is a number, and I will just scan all of the thingies, all of the coordinates into basically an array. Now, let's think on it. I have no idea what the second part will be. But when if we have a number, we have the start position of the number and we have the end position of the number. So those will be relevant to actually calculate the surrounding part of the number because we're gonna need to see if there is an element in that. We can have a start, that's a point, and an end, that's a point. And another condition of the task is that the start and end are not inclusive, but they have the same. And note that when we're doing software development, sometimes when we're displaying a matrices, things get kind of switched around because we have rows and columns. So this is the X and this is the Y. So we have the X coordinate is actually vertical and the Y coordinate is horizontal. So always take that into account. Um, which means that for a given number, this thing, the X coordinate, is the same because they are the same distance away, they're on the same line. So we have the elements and we have the parts, which is a part number array. And since that's all there is, aside from the dots which represent empty, I think we should be able to kind of map that. Let's try it. So we're gonna read the input lines. We're gonna say const. Okay, now we can make this type safe. The puzzle doesn't take a string array, it takes an engine. So this is an engine, and this is an engine, and this is an engine, and we're returning a number. Yeah, so an engine doesn't have a length. We can just say -1 for now and -1. And what will we do in part 1? We're not doing part 2 as of yet. So what will we do in the input processing? That's kind of the big thing. So we're gonna go line by line. Do we want to have a for loop or a for each loop? For of loop. I think we're gonna need to have a for loop, and this is not index, this is x index. That's the input. And first of all, we're gonna need to define the result, which is an engine. And it will have an empty elements and empty parts arrays. So now we need to go through the input. And this is not an element, this is a line. And and we can just say split it on this so that we can use all the fancy thingies. I'll add a helper. It could be done in a better way, but sometimes I do want to have this. Python has this built in for as far as I know, but yeah, this is ugly, but it's gonna work. It's bigger or equal to 0 and less than 9. There's just no way in JavaScript to say that something is a string of length 1. But we can do that. So now we can say for, and again we're gonna need a for loop, because now we have the y index, and this is not the array, this will be the line index, and I know that I will need the current value. Because what happens when we are parsing? Something that we're going to do. So we'll get to the 9 here. Or let's zoom it in. Let's say we're parsing this line. We get to the 6. We need to remember the current value of this 6 because its value, it's not finished. When we're reading this tree, we need to remember that we had a 6 before that, so this becomes 63. And when we get to this, we also need to take care of that. So if the number starts and it doesn't stop until we get to some kind of a stoppage character. So basically, we either get to a dot or we get to a something that's an element or we get to end of the line. So those are the options when a number stops. And then when we read this 7 character, we can say, okay, we're done. And I think this is the hardest problem over here, to basically get the numbers. So now if we can say just if the element is a dot, then for now we can just continue. We will come back to this. If the element is digit, then we're gonna need to do something. Otherwise, it's not an element and it's not a digit, which means it's a, what would we call them? It's an element. So this is a really bad name, so it's a character. Otherwise, it is an element, which means that result dot elements dot push, and we need to add an element, so we have the x index, the y index, and the character itself. So what happens when we have a digit? So this will be actually a part number. That will have the value of 0. Actually, we know the value of x. Index, x index. Does this make sense? Well, somewhat. Not really. We're gonna use now. It's not often that I want to use null, but sometimes it's useful. So, what we want to do? If the current character is a dot, if the current character is a dot, and let's say this is the part number. Just call this part number. This is the part number that we are currently inside of. So, if we are currently inside of a part number, that means that once we get to a dot, we're talking about this dot. So if we're in this dot, what we need to do? We need to finish this thing to say, okay, it's done now, and we need to save it. If we don't, and of course, we're gonna annihilate the current thing because we finished that. I think it will be clear if I write this. So if we have a part number, then it means we came to the end of that part number. We just need to set the final part of it. If we have a part number, come on, this is wrong. I think it messed up a bit because this is not a never, but yeah, this is what we actually want to say. We want to specify that the end was actually not this one, but this one, the previous character. Because we're already on the dot beyond the last thing. And then we will add that part number into the array of parts and set it to null. So when the next dot arrives, this will be null and nothing happens. So if this thing is a digit, then we have something like this. I think this is not a good code, but we'll see. So that means that we're getting to a digit. We have two options. Either we get to a digit before getting, and before that it was not a digit, or we are getting to a digit and before that there was a digit. So, two distinct cases. If we got to a digit and before it was a digit, that means that part number is not null, which means that we just need to update the end and we also need to update the value. Because the value is the previous value times 10 plus this. And we are not adding that to the list of params because when we encounter the 4, we will open our part number processing. We encounter the 1, we are continuing. We encounter the 1, we are continuing again. Only when we get to the dot, we say, okay, we move past, finish it, and do whatever you need to do. So actually, this is not necessary. So, if we have a part number and we're on a dot, we need to continue on with it. Actually, I will move this piece of code here because I think that we'll need some more refactoring. So, if the character is a digit and we're in the middle of a digit, of a number, not a digit, then we actually update the end, update the value, and that's it. Otherwise, if we are getting a digit but we're not in the middle of a number, then we need to do this. And actually continue can be here because if it's a digit, it's not a dot. Otherwise, we're setting a new part number when the value will be, so in the 411 case, the value will be 4, the start will be the index, the end will be the index. So each time that we're moving one away, we're just updating the value and setting the end. The start doesn't change, the start is only set here. And if we don't have a digit and we have a part number, then we just push that part number. So right now we only have digit-wise two options. It's either a digit or not a digit. So it doesn't matter whether if it's a dot or if it's an element. But if it's an element, we actually need to add it. So this will continue the processing of the line. And there is one more option that we didn't consider. This one. Because this one doesn't have a dot or an element after it. So in this case, what happens that we are left holding an object as a part number actually at the end of the for loop. So if the for loop finishes and there is a part number, then we also need to add that because that means that the line ended with a part number. So I have no idea if this thing will work, but I think I'm eager to try. So let's try that. Not that, this, and we can say npm start 3. I don't know why, but whenever I'm recording, the recording software kind of slows down my computer, so especially PowerShell. So you saw that this thing is not too much slowed down. It's definitely operational, but this thing is slow as molasses. So we got our results. Well, and we have good news and bad news because console log goes up to a certain depth. So for the elements, let's check them out. So we have no elements on the first line, line 0. We have one element that is 1, 3, and that's a star. And then on the third line, we have a hash. On the fourth line, we have a star. On the fifth line, we have a plus. Two lines with no, and then a line with two on positions 3 and 5, and those are a dollar and a star. So yes, seems that we got those correctly. But for the parts, we have 467, 114, 35, 633. We don't have a case here when we have a number at the end of the line, but that can be changed. The good thing about having a test thingy is that you can change it. So let's see if our code now will give us this value. And here it is, 6337. I would like, however, to, let's move that here because we'll get something different in the answer. And one more thing that I'd like to see, console.log input.parts of 1, of 0. Yeah. So just log the first part completely so we can take a look at it. Okay, here are the results, and it says it starts at the first position and it ends at xy x0 y2, and that seems to be correct. Okay, so now we can actually proceed to solving this. I'm not gonna be too efficient with this, I think, but it will get the job done. So what I will do, I will just loop through all, no, not a regular for. We don't need that. I will just loop to all the numbers. Yeah, I won't use map. It will get, or filter, it will get kind of complicated, but I want to do something like this. For each part number of input.parts. So we need to see if there is a element somewhere around it. That means that we need to say, okay, first of all, we need to say if the part number dot, yeah, the value is no, 0, that's not gonna be a problem. But if the start dot x is 0, is the x, yeah, if it's on the 0th line, there's no point in checking if something is in the row above this, because there is no row above this. And since this is JavaScript, I only have to worry about the x's. I don't need to worry about the y's, basically. So if the number of start is not 0, then we need to check whether there is a element in all of the things that are. So we need a regular for, so that's gonna be the this is not gonna be efficient, and I can make it more efficient, but first of all, let's see it if it works. So if x is not 0, then the element we're looking for, and I'm gonna call this x, has a value of part number dot start dot x, which is equal to dot end dot x minus 1. So we're going to on the row above. So we're gonna set a value of ey, which is gonna start at part number dot start dot y minus 1. Since this is JavaScript, we actually don't need any checks. We will just check if things. So if something gets off the array bounds in JavaScript, that is generally an okay thing. So it won't throw any errors, and everything outside the array bounds is undefined, so that will just work. So for each of that, we can run a check on the top line, on the bottom line, on the left, and on the right. Those are all the checks that we want to do. So top line. Top line is ax is equal to this, and we will reuse this. And I just needed that in order to do this. So this is an ugly for. Never do an ugly for. So it should go up all the way up to the part number. Oh no, path. I again imported something I didn't mean to. To the I kinda got tired of writing part number all the time, so we can just have start and end. And dot y plus 1. So we are taking care of the diagonals as well. The case is that if we have the number like this 35, we're gonna check now. The 35 has two values, but we need to check four values in the one above it. So it's gonna be start minus 1, then start, then end plus 1. If there is an element in any of those, we're done. And that's not an element, that's a check place. So the check place, actually we have a ex and element x and element y, and the check is whether there is an element that has an x that is ex and a y that is ey, whether there is an element inside of that. We could make this find much better. So the check will return an element or an undefined. And if the check succeeds, we can just say we're done, and continue won't help us here, but we're gonna need to do this. We're gonna need to have a boolean, or we're gonna need to have a goto, and I'm not gonna use a goto. So we're just gonna say, yeah, we found one. And we can break this for loop. We're done. We found. And if we found it, we're gonna continue this for loop for the next input part. So we checked the line above that. So now we're gonna check the line below that. So we're gonna have ex being the start of x plus 1. That's the line below us. And then this code is exactly the same, because now we're checking for the 35 these four. And this will be exactly the same. And now we just need to check two more fields, because a number is on a single line, and we have the one that's the element that is here and the element that is here. And this will actually work for this element as well, because the element that is here only has an index of -1, which is invalid, so it doesn't exist, but we don't have to do a lot of ifs. So we can say so that's gonna be x is gonna be, well, the x star.x, and y is gonna be star.x -1, the one in front of it. So if this element exists, and this is wrong, I had a bug. We don't need to push the check, we need to push the point itself. So we kinda need the value. We need to push the value. So we don't even need the found true, we can just say matched pushed value. And we can directly continue because we don't have a nested for loop. And we need to do the same thing about the end, and Because I like symmetry, I will put and here. And let's see what happens. And just for the fun of it, return matched.sum. I have some helper methods. This is one of them. Let's clear this and run this, and we'll see what happens. So we got 467 is matched, 35 is matched, 633 is matched, 617 is matched, 592 is matched. We skipped 58. 755, 664, 598, and the sum of the parts is 4361. Looks like it might be working, so let's try it on a bigger scale. And we need to note that it only took 8 milliseconds, and to be honest, most of that was spent actually displaying things on the console. So the bigger input, and we're gonna comment out the console log, and we're gonna start it here. Well, that was significant processing time, 213 milliseconds, and the result is this. If it's correct, all is forgiven, but first, let's check. That's too low. So, we're missing something. So now we're gonna have to debug. Okay? No problem. Let's return the console log matched, and let's see if something happens here. So, to make an already long video shorter, now I will need to actually display the unmatched ones and see if they are correct. So we have two possible issues here. We are either matching something that we shouldn't, or we are not matching the something that we should. And to be honest, I have no idea which one it is. So we have something like 909 matched, and otherwise, let's see how many unmatched we have. Let's actually bring back the small input and see if it's matched, if found, continue, if found, continue, if found, continue, continue. So if we didn't do anything, then we need to add it to the unmatched. Yes. So let's see what happens here. Here everything is okay, which means, but note that we already know some of cases that do not appear in the actual case here. So I will take the big input, run it through everything, and then see what we missed. It said that the answer is too low, which means most likely something that is not matched should be matched. So let's see how many of those we have. And I hope it's not more than 1,000, because we might need to go over them one by one. Well, the good news is it's less than 1,000, but it's still about 300. So we're gonna need to see. And most likely it's some kind of a boundary condition. So it's 838. Yeah, that's correctly unmatched. 44. Is that... Yes, again, that is correctly unmatched. Let's move that over, so we have 43. Oh, this 43 is definitely next to an element. So that's yep. That 43 is next to an element, and we can see that we have an ampersand in front of it. And I think that those of you with sharper eyes already were screaming at me for a while because the error is that this is not X, this is Y, actually. So, assuming we don't have any other bags, let's try once more. I think we're gonna match some more items now, and let's see how many there are. Okay, we got our results and now it's significantly bigger. Seems that we missed a lot of those. We're going back to the thing and let's see if that is the right answer. And of course it is. I mean, of course, after we solved it, of course it is solved. So the engineer finds the missing parts and installs it. You jumped in the closest gondola. You're not going very fast. Phone labeled help. Look at the window, stands the engineer. Aha, it's not moving slow, it's standing. One of the gears is the engine is wrong. A gear is any star symbol that is adjacent to exactly two part numbers. Ah, so this is a gear. It's the gear ratio is the result of multiplying. Okay, this is stupid. A gear ratio is a ratio by definition, so it's something divided by something. But if you say multiply them, of course we will. Yeah, that's a gear, and that's a gear. And which one isn't a gear? 617, yeah, that's not a gear because it's only adjacent to one. So exactly two part numbers. Yeah, this might be a trick because it is exactly. So we actually need to do the other thing now for part two. So for part two, we just need to, okay, now I'm going back to the small input again. Let's see what happens. So for part two, we first need to take all the gears, actually post potential gears. Those are the input dot elements dot filter. Well, each element when the value is a star asterisk. Let's see how many potential gears we have. Did I enable the part 2? I did, so this means that we can try this. Yep, it recognized the 3 potential gears. Now we just need to have some kind of a way that's gonna loop through the gears and count there. Yeah, so let's say let total equal 0. And we're not gonna need to say for of P gear of, actually we can just call it gear here. For every potential gear of potential gears, we need to count how many elements there are, part numbers there are. So that's only 8 places. But okay, we didn't have the best structure for that because we have start and end, so we're gonna need to write some math. This start and end was actually good for the first part, but it is gonna be a bit awful for the second part, but I'm sticking to it. So we have 8 positions where we could touch a number. And we have an additional thing because this thing actually touches a number in 3 places. It touches this one on the 7, it touches this one on the 3, and it touches this one on the 5. And same here. So we need to make sure that it doesn't touch the same number twice. So 8 directions, we can just see them. So, but on the other hand, maybe we can do some magic here. So we have top left. Yep. Input dot elements, and no, it's not gonna be this simple. It's gonna be input dot parts dot find some parts. Actually, I will make a helper function for this. Const find part that says it takes an engine and takes, so let's not do an engine, we can just say part number array. Oh, sorry. And takes an X and a Y, and we'll see if there is a part over there. And it might be something like this. And I will reuse that all the numbers have a single X. So its start X is always equal to this. So I can have this, and I can remove this condition. So the start of the Y that we sent is bigger. So the start is less or equal to the Y, and the end is more or equal to, is it the other way around? One way to check. So if we are sending 5, for example, and we have a number that goes 3 to 7. That means that 3 is less than or equal to 7 to 5, and that 5 is less than or equal to 7. Now we're always starting with the p dot, and then 7 is less than or equal to 5. This is wrong. Bigger or equal to 5. Yeah, so this is correct. Thank you. So I will just say find part input.parts, and we're gonna have gear x minus 1 and gear s. So that's okay. Let's see if Copilot can manage this. Yep. It actually messed up because top right is gonna be the other way around. So I will have this correct because this will be very hard to debug if we don't get the indexes right, because this you kind of assume that we have a normal coordinate system, but we don't, because x goes this way, y goes that way. So top right over there is actually the x is negative and the y is positive. Bottom left, the x is bigger, and here the y is smaller, the y is bigger. On the top, we have the x minus 1 and y. On the bottom, we have x plus 1 and y, which means that on the left we have the same x, but y is 1 away, and on the right we have the same x, and what I will do here will be a trick. I will try to do a trick, actually. It might work. A set of not a number, but of part number. Because technically, for this star, bottom left and bottom will both return a value. Three of those variables will be defined. So we will have top left, bottom. Three of those will have values. So I cannot just say count the values. But what I can do is now say parts dot add. Well, I think add was able to take multiple values. Did this have multiple values? No. So yeah. Why? Oh. Now it doesn't want to take on undefined, which I totally understand. If tl parts are tl. If tr parts are tr. Of course, I can reuse the same variable, but they don't charge me by the variable, and this kind of looks standard. So, of course, if I had to use this quite a lot, I would come up with a cleaner solution. But for now, it makes sense. So, we're doing all the adding, and now we can just say, is the size of the parts equal to 2? If it is, well, add it to the total and then just return the total. Since the sets in JavaScript work by reference, this should work, and we already have a case when this will be kind of a problem for us. Let's see if that is actually what happens. And the result we're looking for is 467835. Okay, we'll see. And of course we got 43 instead of that because we did something else. Yeah, Copilot suggested to add this, but we actually had to get the numbers outside of the parts and multiply their values instead of this. Parts dot values. This returns an iterable iterator of part number dot map. No, this map won't work, but we can always put this into an array. And now we can sum them up. No, we cannot sum them up. We can map them to a p value, and then we need to make a product. So this will return an array of values, and we can actually, yeah, this is going to be an ugly line, but it's going to be operational because we know that there's exactly two of them. So we're just going to say this is the first one, this is the second one, and yeah, that. Let's see what happens now. And we got a value 467835. Seems like a phone number 467835. No, it's not that one, but it looks to be correct. So once again, huge input, and let's see where we messed up right this time. It's quite possible that we did mess up somewhere. So we got a huge number, that's 59 million or something like that. So if it's correct, it's not gonna be by accident. And if it's not, it's definitely gonna be a problem. That's not the right answer, your answer is too low. So this video is getting long in the tooth. The answer is around here somewhere, but we will have a part 2 when we analyze actually what went wrong in this one.